potassium. What? Am I changing what these are? I'm just clicking. Boom! Explosions everywhere. Just add them all in here. This is. Mix them together. Put them all in there. Explosions. Right, well I guess that's it. Just to see the effects of what happened. You're not combining them and make nukes. I want to make nukes. It's kind of like a dark ambient theme song going on here. Rubidium is a soft, silvery white metallic element of the alkali metal group. Elemental rubidium is highly reactive with properties similar to those of other alkali metals, such as a very rapid oxidization in air. Natural rubidium is a mix of two isotopes. 85Rb, the only stable one, constitutes 72% of it. The remaining 28 is slightly radioactive, and here's what happens if you put it into a petri dish of water or something. It explodes. Caesium. Caesium is a soft silvery gold alkali metal with a melting point of 28 degrees Celsius, that's 82 degrees Fahrenheit, which makes it one of only 5 elemental metals that are liquid at our near room temperature. Caesium is an alkali metal and has physical and chemical properties similar to those of rubidium and potassium. The metal is extremely reactive and pyrophoric, reacting with water even at minus 116 degrees Celsius. That's minus 177 Fahrenheit. Boom! Explodes, bitch! Lithium. Lithium is a soft silver-white metal belonging to alkali metal group of chemical elements. Under standard conditions, it is the lightest metal and the least dense solid element. Like all alkali metals, lithium is highly reactive and flammable. For this reason, it is typically stored in mineral oil. When cut open, it exhibits a metallic luster, but contact with moist air corrodes the surface quickly to a dull silvery grey, then black tarnish. Because of its high reactivity, lithium never occurs freely in nature, and instead only appears in compounds which are usually ionic. Boom! That's it dissolving away. Well, there you go, that's this. Yeah, I can see this being useful in classes, maybe. Sodium, I've already done that. Sodium is a soft silvery white, highly reactive alkali metal. The free metal does not occur in nature, but instead must be prepared from its compounds. Sodium is the 6th most abundant element in the Earth's crust, and exists in numerous minerals such as feldspars, sodalite, and rock salt. There's your salt. Potassium. Potassium is in nature occurs only in ionic salts. Elemental potassium is a soft silvery white alkali metal that oxidizes rapidly in air and reacts vigorously with water, generating sufficient heat to ignite hydrogen emitted in the reaction and burning with a lilac flame. It is found dissolved in seawater, which is 0.4% potassium by weight, and is part of many minerals. And there you go, that's what it does. Well, there you go, guys. That was a quick look at Chem Grab, and yeah, I can see this being useful. They should probably approach schools with this idea. It's a good idea, and it would save, you know, health and safety kicking off. But you should be able to mix compounds and stuff like that. That would make it more exciting. I guess you kind of, no, you can't. It's just their individual reactions. So for next step, I'd say you should be able to mix them. because you want to blow this dish up. You know, that's the end goal here. Should be to blow that dish up. Alright, hopefully you guys enjoyed. Hopefully you learned something. Kentish.